Master in Petroleum Engineering. So today I will talk about this Micromodel test rig equipment, and we will learn how to run this equipment, what is the operating procedure of this equipment, and the challenges. So let's see. Let's learn the individual part of this equipment. Firstly, I would like to talk about this pressure maintaining valve. So the first one, this one is for nitrogen gas and this one is for carbon dioxide gas. So this one is indicating, this one will indicate when you will increase the pressure or decrease the pressure, this one. And this one, you can see that it's indicating the pressure is 700 psi. That means this pressure we already has given in the cylinder. That means our cylinder is placed outside the lab and it's connected with these lines. So if you want to increase the pressure, then move it like this, then it will increase like this. Or if you want to decrease, then like this. You can see there is one switch, it's power, and this is for your operating. So if you when you will start operating this one, on this one, now you can see that the power button is giving us green signal. That means now it will work. And then you can see there is one alarm, and there is also a function for this alarm. I will talk about this one later. Then this is the emergency stop, this is the light. So this light is currently on, that's why you can see there is the light is on. And I will show today the Micromodel. So that's why our Micromodel is switched on. And for core flood, I'm not talking about this one. You can see there is 4 different valves, 1, 2, 3, 4. So the first one is, that means our V3. When you will on V3, the fluid will come from the first cylinder, from this cylinder, the fluid will come. If you on V2, the fluid will come from the second cylinder. When you will open V1, the fluid will come from this one. This is for foam generating. If anyone wants to work with the foam generating or foam flooding, then they need this one. And currently this one is not working. So if anyone wants to work with this one, they have to fix it first. And the third one, the fourth one, that means the V9, this one is directly connected with my carbon dioxide and nitrogen gas cylinder. So this is the Micromodel system. Inside it we have our Micromodel. So this is a window from which you can see that the fluid is coming or not, the fluid is flowing or not, or the glass is broken or not. So it's a very important part. And then there is one valve. This one is, when you will open this one, it will flush all the water inside your Micromodel. So when you will work with this equipment, you have to be very sure that this valve is closed. Then there is one valve. You can see this is connected with our Micromodel. Whenever you will open this one, if I open it, you can see some water just go through this line and it back to this container. So this one is for maintaining the confining pressure. Then there is a V5. If you on V5, then this motor will collect water from this one, this container, and then it will supply the water inside this system. So now there is one valve. This valve, you can see it's indicating towards carbon dioxide. That means it indicates that when we will increase the pressure in carbon dioxide cylinder, it will permit carbon dioxide to flow through it. So if we switch it like this to nitrogen gas, then it will indicate that now it's permitting nitrogen gas to flow, not carbon dioxide. So now we just switch it in the face of carbon dioxide. That means now it's permitting carbon dioxide. Then our carbon dioxide will go through this and Okay, then it will come, and you can see there is one V10. So if we on V10, it will indicate that we are permitting carbon dioxide to go through this, and it will go from this line to directly in this valve. Okay, in this valve. So whenever we will open this valve, that means from this line to the cylinder. So when we will open this cylinder is filled up with carbon dioxide gas or nitrogen gas. Which one you need to run your experiment. And this one should be open also. This one should be closed. After filling up the cylinder, close this one and close this one also. For this one, the password is Code over 2017 for this desktop. Code over 2017. So when I just on this one, now this is we will use two kind of software for our experiment. The first one is Micromodel system, and the second one is control pump panel. So firstly we have to open Micromodel system. So when I will start on this one, after that we can see that what is coming. Okay, now you can see in this screen there is one option run and one option for stop. Now it's in stop condition, so now we will run it. We already on the power button, that's why now this software can take all the pressures from this pressure gauge. So now my BPR pressure is 4, my pressure inside the water cylinder is -2, pressure inside the oil cylinder is 20, then my injection pressure is 12, my DP inside is 11, and my outlet pressure is only 1, and the confining pressure is 3. So in this software also we have to learn something, like for this confining pressure helps to maintain the pressure inside this Micromodel. Suppose we already said the difference between PS1 and PS2 is 14. That means the injection pressure and confining pressure 14. That means when my injection pressure is 12, my confining pressure will be 52, because they have 40 difference. And then for our injection pressure and our outlet pressure, you can see here we have a difference between these two. How much? It's almost 10. So this is the difference between our inlet and outlet, DP. This is the pressure inside our gas, inside our glass. And then the thing is how this confining pressure is maintaining. Suppose we are our pressure is increasing here from firstly initially it is 10, then it's increasing because that time we will increase the BPR. Suppose my BPR is 500, so now my injection pressure will try to increase because the BPR is 500 and the outlet pressure is almost is high because of this BPR. It's like when the injection pressure is 11, my outlet is 1. When the injection pressure is 20, my outlet is 10. Like this, it will increase. So for that one, when it will be 100, confining pressure will be 140. So when this pressure is increasing, this pump is injecting some fluid to maintaining this pressure inside the Micromodel. any leakage happen, that means the water inside that system, it's going through the micromodel and it's flushing through V7. So if it happened, what will happen, that the water is going through V7, that means there is less water inside the micromodel. Then our HP syringe will inject some water again to maintain the pressure. So this is the function of HP syringe, and this is the function of our confining pressure. Now we are going back to, and this is the ISCO pump. So the function of a ISCO pump is, this is a dual pump. Dual pump works for this equipment, and this equipment, this pump is basically they made it for those kind of experiments which need a long time. You need to run this equipment long time, like 8 hours, 10 hours, 12 hours. So it's not possible to run any pump continuously 10 hours or 12 hours. So there is two pumps. Suppose this is pump A and this is pump B. When pump A works, B is standby. When pump B works, A is standby. So for this one, suppose it will inject 100 ml water. So firstly, when this one is injecting the water, when it will go 25 ml, that means it has left only 25 ml, that time the pressure, it will change the pump, because this pump is already full, and when it will change the pump here, that means A will start working, and in the meantime B will fulfill. That means it will refill B automatically. We don't need to operate it. It will change and it will refill automatically. That's why this equipment is very expensive and also very sophisticated. So for this one, firstly on this. So now this is the thing, it's already on, and the main thing for this equipment, this one, there is an air supply. This one should be on every time, because this air is helping to inject the water, to fill and to inject it in my accumulators. So you can see, if this one is closed, that means if you want to refill, what will happen, there is no air, and you will see that the pressure increases to 10,000 to 12,000. It's very harmful for this equipment. So every time starting work, when you will start working with this equipment, be sure that this one is on. That means the airflow is connected with this line, and this is my distilled water from this container. This pump takes water and refill it time to time when it needs the water, and this pump is connected with our accumulator. That means when it will supply the water pressure, because of the water pressure, my fluid will be injected towards my micromodel. So this is the function of this one. If it doesn't work, that means the injection process also not working. That means it's not supplying any water to our accumulator, and accumulator can't inject any fluid, because it's injecting the fluids and it's increasing the pressure through injecting the fluid. So this is the function of this one. Now we will go. Okay, before starting any run, we have to fulfill our accumulators. So if you are working with brine and oil, this cylinder is for brine and this cylinder is for oil. And now how to open this one from this system? Firstly, close it from this side. Okay, I also can mention this one, that my water from ISCO pump comes from this line, and it keeps pressure in this side like this, and it gives pressure like this, and my fluid go through this line and to this, and when we will open this one, it will go through my Micromodel. So this is the lining system. Now close this one. If I don't close this one, then when I will open it, a lot of water will come. So close this one first and close this one also. This is the inlet. These are the inlet for water, and this is the inlet for my brine. Okay. Okay, now opening. So for this opening, this one, you don't need to give a lot of pressure, just hand. Use your hand, and then this one. Okay, just use your hand. Okay. Currently in this accumulator we have brine. The last student who worked with this one, this installed their brine. So now okay, so now if we want to open this one, our first work is to open this thing. Why we are opening this one? If this one is closed, that means inside my accumulator it's air packed. That means fluid and air. So it's very packed. So when I will open this one, that means some fluid can come and some air can pass through this line. Now we will open. Okay. So the first thing is opening this one. It's very tight. If you can't do this, then just use one adjustable panas, connect it here and do it. So it's already, you can do it easily. But just. So if we want to flush the extra water from the accumulator, we need a system like this. This is a air flow regulator, and we will connect this system with my accumulator using this one, and this one I will connect with a air supplier. Okay, so now it's already connected. This is the system that when my work is done, make it like this. When you want to increase the pressure, just move it like this. So for our flushing, it's only, we need only 35 psi. So let's see how to install it. See, now I'm increasing the air pressure. That means I'm permitting the air to flow. It's flowing through this line, and from this air regulator, airflow regulator, I will increase the pressure. And in the meantime, today I'm not placing it inside it, because I want to show that how the water comes from this one. So you will see, everyone will see that the water comes in a very high pressure. Yeah, the water is coming. Okay. Okay, so you can see here the magnet is now in this place. It was here, now it's here. That means there is no water left inside the accumulator. So previously the magnet was here. When we give this pressure, this airflow, it flushes all my water, and now you can see the magnet is here. That means there is no water left inside the accumulator. Now we can install our fluid again. So for installing, first, and now we have to remove it. No. So firstly, close the air supply. Just like this. Decreasing the pressure. It's 0. So open it. Okay. Now close. Close air supply and done. Okay. Okay. So this one is totally now opening it again to install the brine. Just cleaning inside the accumulator, and be careful with that ball. And install the ball back. And now, okay, it's almost clean inside it. Now we will install our brine. So for per installation, we need 700 ml of our sample. So it's like also 700 we need. So maybe we can. It's 500. So I'm just making it 700. So it's almost 700. And now you will see if there is any kind of fluid coming, that means it's sealed properly. Done. Now we have to install. So this part should be in that side, and this pressure gauge side should be in front. So we are installing it here again. How we open it from this part now? We need always try to make it with your hand, because if you can do it with your hand, that means it's okay. And then this one, the brine one. Okay, done. The brine one is done. So now also, if you want to change your oil, you can change it. The same procedure I have done for brine. The same procedure. So after that, now first thing we have to install our micromodel here. So I will show how to install the micromodel and how to reinstall it. So firstly, inside it there is some water, because the previous student who worked, this one is in that position. That's why we have to open it. So if we open this one now, it can't flush because there is no place to remove the air. So just open it for supplying some air. Yeah, okay. Because of air. Okay, supplying some air. Now I'm opening this one. Now it can flush all the water. So you can see it's flushing all the water inside the micromodel system. So why we are basically why we are using water to fill this up? The first thing is to get the proper visualization. It's easy to get the proper visualization through water. And secondly, if anything happened inside the micromodel, then this water will prevent the excessive sudden pressure difference or anything. So for this one we use water. So when the water is already flushed, now open it. Okay, this one is disconnected. So if we can disconnect, now we can disconnect this one also. We can open this one also. Now we need one equipment like this. This one will help us to open it. So we have to open these all of these screws. And place it like this. So this is the upper part. We already dispatched it from the system. So this is my micromodel. This is the micromodel casing, and we can see that all the water already flushed. Now I will open this one. So how? This one we need one panas like this. So open it first. Okay, so it's already done. Now that side. You have to open. There is another one. This one is for moving it. So when I will move this one, now it's easy to dispense it. Okay, maybe it's not open. Okay, now we can dispatch it from this slide. So this one is the casing with my micromodel. Now we will see how to open this one. Okay. So now I'm opening the glass, the lower part, that means the plain one, very carefully. If we do without any carefulness, there is a chance of breakdown of your glass. So these glasses are very expensive, so be careful about the glasses. So this is the glass. This is the lower part. You can see it. Okay. And now the lower gasket. And so it was attached with this platform. This is made with silicone. Now I again dispense it, separate it from that one. So now our second thing is to install it back to show everyone that how to install it. Okay. First thing, install this. There is two silicone. It's not silicone, sorry. I already forgot the all. This upper part. Okay. And the first thing is, sorry, to install this one, we have to install this one first, so that you can see there is 5 points. One is for inlet and the other points are for our. So 1, 2, 3, and the last one is 4. So use this one now. But not so tight. just do it like this, this, but be careful, no tight, not so tight. Okay, so now this one is disturbing us. Like this. So if when you will give some light through this, you can see from this inlet that there is no blockage. That means no gasket blocked it. If you can see that, you can see only the glasses. That means there is no blockage in the inlet. Then we will check it with our outlet also, because this is the most important thing. If there is any blockage, then no fluid will come. And like this, okay, it's also, there is not a lot of blockage, it's okay. And now the inlet, from the inlet you can see there is no blockage.
Okay.
If sometimes gasket block this inlet or outlet, so
okay,
if you see that there is no blockage, then you can start. Otherwise you have to open everything. And now I will install it back. So for installing it back, the first thing is install it here and connect it like this. Now tighten it with your hand first. Tighten it with your hand first. And close this one. If you don't close this one, then if you at the time of leakage detection, if you fulfill this one with water, the water will make leakage from this side. So close this one also, close this one. Now tighten. Now tighten this one. Tighten it first. Okay. The second one is this one. So tighten it. Okay, tighten. Now we will do a leakage detection test. For leakage detection test, we have to fulfill it through like till this. So firstly close this one, otherwise when you will try to fulfill it with water, the water will go through. So close this one first. Now I will fulfill it with water, and we will detect there is any leakage or not. Okay. So we have to do it manually. Till this. Why we are using water? If there is any leakage, when we will flow air through it, if there is any leakage, the bubble come out. Okay. So now open this one, V11. Open V11 and increase the pressure. So you can see there is a lot of bubble coming. There is a lot of bubble coming. That means in these places there is leakage. So till now, so make it more tighter, tighter, tighter. The procedure is like this. So you have to tighten it till there is no leakage. So now you can see the leakage is, it was a lot of leakage it was showing. Now the leakage is very low, so just try a little bit to fix it. Just disappear all the bubbles so that we can differentiate that which one is happening. That means there from this side some leakage is happening. You can see, you can show the desktop. So for the SOP, the first thing was brine and oil installation. I already said that how to install brine, how to install oil, and I already do the things for you. And then the second one is install it and leakage detection. I also do the same thing, how to install it, how to open it, how to do the leakage detection, everything I already said. The third one is Micromodel fill up with water. So for this one, the first thing is open V5 and V6. This one is V5, this one is V5, this one is V6. Open V5, V5 and V6 and V6. Okay. So button. There is, the first one is system button, second one is motor reverse button, third one is high speed button, fourth one is gas booster button, fifth one is heater button, and the sixth one is water pump button. So they say to turn on water pump button. So I'm just turning on the water pump button. So now this pump is working and it's taking the water from this water container. Fulfilled already, that's why the water is coming from the Micromodel to the container through this line. So now we have to close VC, V5 and close water pump button. So this one is now, this Micromodel is now fulfilled with water. Now the next step, is confining pressure. So for confining pressure, the first thing what we need to do, refill the syringe pump. So for refill the syringe pump, there is one V11. This is the V11. So change the direction of V11 towards the water tank. Towards the water tank. So I change the position of V11 towards the water tank. That means it indicates that it will take the water from this tank. And click motor reverse button and high speed button. So I'm clicking here motor reverse button and high speed button. So when my syringe pump will be fulfilled with water, that time it will give here a green signal, reverse limit alarm. So let's see what happens. Wait. So now the HP syringe pump is already full. That's why motor reverse button is switched off automatically and the reverse limit alarm is green. That means now the HP syringe is full. So now injecting our confining pressure. Firstly, we have to change the direction of V11 to upside. like before. So I already changed it to upside. All the lines and valve should be closed. All the lines and valve means V6, V5, V11, then these 4. Okay, all the valves are closed, and also this one, V7. And now they say now switch on system button. So I'm switching on system button. Okay, now system button on, and we will see that our confining pressure will increase very soon. So when it will be 40 to 45, then we can start for our further procedure. So after 10 minutes we see there is no fluid is coming. No fluid is coming from our outlet. So the next step is carbon dioxide pressure increase. So this one is not for carbon dioxide pressure increase. If you want to work with nitrogen, the procedure will be same for nitrogen. If you want to work with carbon dioxide, the procedure will be same for carbon dioxide. Or if you don't need to do the experiment with carbon dioxide or any gas, then you don't need to do this part. This is the additional part who wants to work with any gas. So now carbon dioxide pressure increase. So here we can see they already supplied 700 psi from the cylinder. So now how much I want for my experiment, this is for, I will set it now. So the first thing, if you want 2000 psi, then you have to set the cylinder till 2000. But now I will do it for 100 or 200. So it's okay for 800, for 700. So okay, we can see the pressure is almost more than 150. So now the pressure is 150. So after that, what they say, regulate valve from the lab and set. Okay, I already regulated it and set it. Then select the valve towards carbon dioxide. So this valve, I already talked about this one. This one already, the direction is towards carbon dioxide. So then select the valve. Okay, open V20 first to release the inside gas. This is our V20. So I'm opening this one, release the inside gas, and now open V10. So I will open V10 because now my carbon dioxide is still this point. When I will open this, then it will go through the line. So I'm opening V10. That means my my gas already go through this line, and then this one is open already. That means from this line to inside the gas cylinder. Now close it and close V10. So my cylinder is now fulfilled with carbon dioxide, 150 psi carbon dioxide. Now the brine injection part. So we can see that the volume is 103 and this is also 103. So now I will stop running. So I stopped running for both. Now make it continuous constant flow, make it remote. When we will make it remote, that time it will work for this. When pump A works, pump B will be standby. When pump B works, pump A will be standby. That's why it's remote. Now change it to constant flow, and this one constant flow, and the flow rate is like 0.5 ml per minute, and only start for pump A, not for pump B. Only start for pump A. Okay. So when I start it, so now we can see the fluid is coming. That means our line is totally okay. But if like this the fluid comes, then the pressure won't increase. Like if we run for 5 hours or 6 hours, the pressure won't increase, but we will lost all of our fluids. So now to stop this fluid flow, we have to increase the BPR. So how to increase the BPR? First of all, close the side valve tightly. When you will close this one, then whenever you will pump and open V8, pump it, you can see the BPR is increasing here. Now it's 44. I'm pumping it. Now it's 64. Now it's 89. So it's 100. So when it's 100, if I set it 100, then it means my system, the system pressure will increase till 100. After that it can't increase. If I set it 500, that means my system, the whole system pressure will increase till 500. If I set it 1000, then it means the system pressure will increase till 1000. So now I need 100. So now I am closing V8. So if V8 is closed, that means the BPR pressure will be like this. And in the meantime, we will see how our injection pressure and outlet pressure will increase because of this BPR. Let's see when the pressure will be around 100. That time we can open the valve for our gas. So suppose I want to change the fluid flow for brine to oil. So I can change it anytime. Like now, if I want to change it for my oil, I can change it. But if I want to change it for my carbon dioxide gas, I can't, because I already set the pressure for carbon dioxide 150. That means if I open this one, it will hit my micromodel with 150 psi pressure. Directly it will hit my micromodel. That's why what I need to do, I have to increase the system pressure till 100 to 150, so that when the pressure will come from this carbon dioxide cylinder gas, that time it can't hit with 150 pressure. Maybe it will hit with only 10 psi or 20 psi. So it's okay for my glass micromodel. So let's see when the pressure will increase to 100, that time we will start again. So now we can see that BPR is 0, outlet pressure, when the BPR decreases, my outlet pressure decreases. When my outlet pressure decreases, my injection pressure decreases and the confining pressure. So when we will see that the confining pressure is nearly 60 to 80, open V6, so that the confining pressure can go back to the water container. So it's now go back to the water container and the confining pressure is only 4. Now what we need to do, close it from here, switch off system button, switch off high speed button. And for this one I missed one part. This is the record page. When you will start injecting the fluid, go to the record page, start record Excel. Then just set the, like if you do this experiment for today, so just make it like 1st December 2021 and then start record Excel, then your everything will start recording. So when you are done with your everything, now go to record page again and just stop here, then your data will be recorded. Now we are going to main page. Now all the pressures are decreased, but there is some pressure inside my water accumulator and oil accumulator. So for this one, open this one. Okay, when you will open this one, the fluid is coming and you will see that the pressure is already less, 14 and 3. So we already decreased all the pressure, and now shut down it from here. Yes, and this one also done. So close this one also. Okay, So we are done with our, this one already stopped. So we are done with our software thing now. So after, when we are done with our software things, now we have to come here because we already switch off the pump and we already switch off the system from the software. So now switch off, switch off, switch off. So it's done with our system, and now we already decreased all the pressure from this system. Only one we can't, that one is our pressure inside this pump, this line. That means there is some pressure, we have to decrease it. So just make it open first, that means lose it, and come here. There is one valve to release the gas. So we will see that the pressure is now 0. So we can see the pressure is already 0. So this is the system, that how we can run this equipment. It looks so sophisticated and very hard, but it's not so much hard. If anyone can run 1 or 2 times, this will be very easy for them also. So it's done for this one. Then just